Hi everyone, thank you for being here. Hi. Just before getting started, I want you to notice one thing. Our original is putting in a presentation which talk about refactoring some cranes, some relating to construction. Are you amazed by that? No. No. Okay. So you're a difficult audience. Okay. I am Michele. I work for Ideato. Ideato is an Italian company which work actually in a lot of stuff, most of PHP. And these are my contacts if you want to reach me. And after the talk, please leave some feedback on that. Yeah, I want to give you a bit of context on how this, well, all this stuff started. Well, we were asked to work on a project for a client of ours, which is in the automotive domain. In particular, was something used by dealers, car dealers, to, well, help manage day-by-day work. So let's say with that software you can contact new clients, see what are the leads for a given client, and contract prices and stuff like that. Okay. The project got a really, really old code base. When I say old, I mean more than 10 years. Some part of the application were still the core, the main part of the application was developed when PHP 4 was still around. So just to get you an idea, okay? And yeah, the application is pretty big. It got a lot of code, and it got a lot of unused code. So there are a lot of functions and classes and whatever. We don't know if they are actually used by some client, okay? Or they're just that code. There's a lot of commented code because, yeah, why should I delete code? I don't know, maybe in a month I could need it again, yeah? Right? No, wrong, but still, it is there. And there is a lot of code whose purpose is unclear. Okay, so there is code, it works, but we were not sure why and what it was supposed to do. Okay? Have you ever been in some situation like that? Yeah.
Why would you do this?
Yeah. Yeah. Okay. So about the project documentation, have you ever heard about living documentation? Which means documentation that evolves as the project grows? Yeah, it's not that. Living documentation is basically 90% of the knowledge about how the system works resides in the head of one developer, like living in this sense. Okay, so so if that developer got sick, got a vacation, I don't know, it escapes, it won the lottery and goes to Brazil. Hi, bye everyone. Okay. And what else? Yeah, there's a lot of procedural code disguised as a object-oriented code. So there are classes, okay, but inside classes you just have big procedural code, big methods with like, I don't know, 1,000 lines, okay, stuff like that. There is, and there were at the time, no clear, well-established architecture. Is like, what are we using, like MVC or stuff like that? And obviously there were no automated tests. Okay, so I want to give you an idea of what I'm talking about, and I tried to put that code in the slides, but I weren't able to do that. So let's see. Yeah, are you able to see that? Okay. This is an example of a, let's call it controller. Okay. There isn't a front controller. So we have multiple entry points in this application. Okay. Which, okay, is not ideal, but is that there are worse things inside that. And yeah, please notice that we still use require, okay, in 2018. What else? This class does a lot of stuff. PDO, it instantiate a template, okay? Yeah, we do have queries in the, like, this is sort of an action, okay? We have queries, and then we get the data, and we work with the data, and then we do this and that, another query, because why not? Okay, and another stuff. Okay, and we can continue, and so on and so forth, and so on and so forth. We also can talk about something like, how was your day in Verona? Okay, no, because it would take a bit of time, so okay, I can continue, but okay, you get the idea. There's a lot of static classes, okay? Okay, and this class in particular is like 4,000 lines. Okay, so you get an idea of what was the situation. But just let me be clear. I mean, this code now works and it pays the bill. So, okay, it's not beautiful, but it still works. Yeah, why changing it? I will come to that. Um, yeah, that's another view of the architecture. Basically, the software is um, as a service. So we have multiple clients. Every client gets its own custom installation, but in reality, the code is just one, which is shared between all the installation. And we have one different database for every client, which, okay, basically is fine. We also have a separate DB for, and a separate application for, yeah, configuration. With configuration, I mean all the stuff that are not supposed to be modified, touched by the client, by the dealer itself, but by an administration, okay? Okay, so, yeah, why should we want to change that? Because working on this code became increasingly difficult over time, as you can imagine. And yeah, so, well, we started and we decided, okay, let's start to refactor something, okay? We choose one module, which is called the mail parser, or for friends, the beast, which is basically a piece of code that fetches mail from an email account, parses them, extracts information, and uses that information to populate the database. So it's pretty, it was a critical part of the application. So we basically just started taking what piece we'd like to improve, wrote a test, and changed the code. Everything went fine. We deployed that, and well, basically we did not fail, but yeah, we almost get there. No, we failed in some way because we broke stuff. Why? Because we didn't know enough about the code. Okay, that was at the beginning of the project. So we tried to change approach. Yeah, thank you. And well, we decided to start um, getting knowledge of the project by pair programming with other team members. Okay, we were the consultant. There were a team of 8 people when we started, if I remember correctly. Okay, and we said, okay, just start pair programming on regular tasks. At the beginning, we don't want to refactor. Okay, we just want to learn how the code is structured. Okay, and yeah, that allowed us to work on 2 different approaches, two different ways, two different angles to take the problem. The first one is code. Okay, yeah, we start working with them and we start improving the code, maybe doing small refactorings, local refactorings, and then also we start passing some knowledge on how to avoid writing new debt, new bad code. Because, okay, now we got two problems, basically. The code we have now is not good, and we want to improve that, and we want to avoid that new bad code will be written. Okay, makes sense? Okay, yeah. At least it makes sense for us. Okay, so localize the factory, as I was saying. Yeah, this I want to show an example on how we use that particular approach to refactoring some part of the code to objects. In particular, the configuration system. Okay, the configuration system, as I showed you before, is the part of the system that contains all the configuration for a specific dealer. Okay, it basically is a gigantic array, a key value, which is fetched. Let me. Okay. Which is fetched at the beginning. Let's say here we have a controller. I extracted a small part of a controller. Let's say we have an action, and here we are fetching the configuration. Okay, the actual code is a bit more complex, but just you to get the idea. At the beginning, we do that, and then like 1,000 line down, we do this kind of stuff. So we are working with the config array, trying to get some values based on some dynamic values, like that. Okay. So this code is not particularly clear to understand, okay? But if you look also at the comment, maybe you can get an idea of what is this piece of code is supposed to do. So basically, we just want to extract two informations from the configuration, a time and the caller ID. Okay. The context here is we want to get information about a client who got in contact with us. Okay. So I want to retrieve these times. So basically, what can we do to improve this code? First step is like, okay, we extract a method which at the beginning is locally. We can call it, yeah, I don't know, get service alert configuration. Okay. Let's say we want to move out this particular piece of code. What parameters do I need in order to perform this refactoring? Well, for sure config. Okay. After that, ideas. The common key. Yeah, it could be. But I could also refactor that in that method. Like the dynamic part. So this variable called lead origin ID, whatever it means. And this. Yeah, also that. Yeah, sure. Say the dd. Again, please notice variable are in Italian and in English, just to spice everything a bit. Okay, and that's enough. So let's refactor that. In this way. Config. Okay, and Yeah, that's right. Now we can just move the code in this way. Okay, return this. Okay, because I forgot this particular part. Okay, so in this way we basically moved out all the code. What do we need to do in order to complete this refactoring? Okay, this should be changed. Okay, and I guess that's all. Okay, that should work. Okay, that's the first step. As a second step, now we can move this method in another class. Why? Because it's not the responsibility of the controller to do this reasoning on the configuration. Okay, make sense? So we create a dealer config, new dealer configuration, and we just do this. Okay, after that we move this code here, PHP class dealer configuration. Let's save that. Yeah, okay. That's fine. We need to move also the static variable, which again doesn't make a lot of sense in the controller because it's related to this particular piece of code. We can do that pretty easily. Yeah. What else? Basically, we are done. Last step. We could, it's not mandatory, but the idea is it doesn't make a lot of sense to construct a dealer configuration object which is meant to hold all the configuration values without the values. Okay, so we could move this parameter from here over there. Okay, also now is clearer what parameters does this method needs in order to produce these results. Okay, and let's go there. Yeah, but to do this config. Yeah. Okay, so and now here we must change it again. In this way. Okay. Makes sense what we did here? Sorry? Yeah, thank you. Perfect. Okay. So basically that was one pattern we used in a lot of places inside the code to just convert plain arrays in object with some kind of meaning, okay? With some kind of behavior. Okay. Are there questions on that part? Okay. So, yeah. What did we do about code organization? Okay. As I said before, there weren't basically any clear code organization in the project. There were some sort of like modules. I don't know if you like. Um, how many of you have ever used Symfony 1? Yeah, You are too young, guys. Okay, or I'm old. Okay, well, basically the idea is, well, a module is something like a context for a particular part of the application, and all the files related to that context goes there in a particular directory. There were some sort of organization also here, but it wasn't really clear. So also we wanted to separate the good code we wrote from the previous one. So we created what we called API Island. Okay, so the API Island was a part in our repository where which contains only good code. What does it mean, good code, in this context? Well, it means that this code implements a few selected patterns that can be replied all of the code. Why we did that? Because, yeah, the idea is to give the team some sort of templates they can start use, okay? Even without fully understand all the patterns or all the code organization. Moreover, we try to enforce some rule on this API Island, on this part of the code. The first one is the code must not use external code, okay? Because we don't want to pull in bad dependency, yeah. And the code must be tested. When I say must be tested, I don't mean we want to have 100% coverage, okay? But at least it should have one test, okay? Or saying it better, it should have the minimum number of tests that give you confidence that that particular part of code works, okay? Okay, we choose two really common patterns to implement here. The first one is modern repositories. I think every one of you knows about that. Okay? Yeah. Okay, so basically the idea is, as I showed you before, there weren't models, there weren't PHP classes. All the code was static functions and arrays. So the idea is, let's start creating some models, some classes that encapsulate the behavior of the system. Okay, and the counterpart of that is, let's use some classes like the repositories that abstract the operation of fetching data from the storage, the database, and saving that data on the database. Okay, I'll show you how to do that in a bit. The other pattern we decided to implement was the use case pattern, which again is not complicated. Basically, the idea is, as I showed you, the controller were really big. Okay, we did have like method with 1,000 lines, and we wanted to slim it. The more we were able to slim it, the better was. So the idea is, let's move the business logic outside the controller in a particular class. A use case is a class that implements one business function. It could be like, I don't know, send an email to a customer, or fetch this particular set of data from the database, or export this particular list of data. Okay? Make sense? Yeah. Okay. So yeah, they're sort of service, but there is a difference. Service tends to accumulate different responsibilities. Okay, so you have a service, as you have usually a service. Most of the time, it ends up doing this. The use case is supposed to do only one thing. Okay. So we started to implement those patterns in this API Island. Yeah, and let's talk about model and repositories. I have a question for you. What happens when you don't have foreign key constraints on your database and you don't have strict data validation? Yeah, nothing good. Yeah. Okay. That was the situation. And yeah, when we tried to think how to solve that, also with the discussion was also about, okay, should we use an ORM or a data mapper or whatever. Yeah, the idea is, well, given the, the the data and how the data were in the database, we wanted to avoid introducing more problems. So, okay, in my opinion, ORMs works very well if you can choose and you can manipulate the data, the tables and the columns. Okay, if you don't have any particular constraints on that. And here we have inconsistent data, no foreign key, and like enum columns used, so doctrine in particular was not an option. And well, so we decided just to write our really simple data mapper. Yeah, I want also to show that how to refactor to a model and a repository. No, model, yeah. Again, there is a small snippet taken from a like enormous method inside the controller. Here basically we have an array which represent here a vehicle, as you obviously can understand, but the V here, which is okay, pretty simple to get that. And okay, basically here we are populating our vehicle with some data, and then using this static method we are asking to save it to the database. Okay. Okay, how can we refactor that? Oops. Okay, we create our vehicle model, and we pass on in the constructor the data we need. So in particular, the first one, the second one, the status. What else? Nothing else. We are done. Okay, and now we can create our class. Oh, sorry. I will not populate it with all the private data, but we have like for sure a brand ID. Yeah, I got that. Thank you. Model ID, status. Okay. And obviously in the constructor we are going to populate that. Okay, I'm not show you everything here, but it makes sense. Okay. Brand. Oops, model status. And then we have brand ID. Okay, brand ID. Okay, so you get the idea. Let's save that. Okay, so now basically we can just delete this code, or comment it if you want, just to no, I was joking. Delete it. Yeah, I saw you. Yeah, you wanted to keep that. Okay. Now here we need a way to just recreate the initial array. And since I have a bad memory, I will actually need to keep that for a bit. And we can create a method like called, I don't know, what's a good method name for doing that? No, I didn't get anything. I just heard like serialize. Okay, don't like it that much, but okay. Which returns an array of data like let's see if we can do something quicker. Yeah. And then here we have this like brand ID, this model ID. Oh, hmm, this, yeah, status. Okay, and then we can change it here. Okay, so basically in this way, you just again move out data, convert it from an array to an object. This can go away. Okay, and we're fine. With this approach, there is something that is I want you to notice. In particular, in this method, basically the model knows how the columns on the database are called, which, well, yeah, in my opinion, is not a big deal, but yeah. There is another way of organizing that, and oh, sorry, I wanted to show that. Yeah, the idea here is to complete this refactoring. We can just create a repository like vehicle repo new repository, which, yeah, uses PDO probably, and then we can just do something like save. Okay. Okay. And also here inside this method we can reuse, probably depends on how bad is that the code in that particular static method. We can reuse that to implement the save method here. There is another approach which is a bit different. I wanted to show that. Yeah, is an example of real repository, which in that particular case implements it's a campaign repository which is used to fetch marketing campaigns from the database. Okay, so it uses a PDO object, or if you don't pass anything, it just creates a connection. And then you have a really, really simple method which is called find by ID, which performs a query on the database. And you're done. After that, you create a model with the data you have just pulled out from the DB. This is another approach of using the constructor. Okay, here we have a static constructor, which means is a static method inside the campaign model, where you just create a new object and populate that with the data you pulled out from the database. Okay, a slightly different approach is moving the responsibility of knowing the database columns in the repositories. Here is an example. Here we are basically fetching negotiations, okay, between the dealer and a particular client. Yeah, and let me show you. Yeah, basically the repository has two methods, sorry. Model to row, which is used to convert from an object to an array which is meant to be saved in the database, and the other way around is the row to model method, where we just create from the data we pulled out from the DB in this way. Okay. Also, here I want to show that basically here we are passing mandatory data in the constructor and optional data through setters. Again, it's not something I actually, to be honest, do like that much, but still, it works. Yeah. Questions so far? No. Okay. Because every one of you is sleeping, or? Okay, no good. Okay. What else? Yeah. Bad idea. We use both approaches inside the code. So the first one where the model knows the database columns, and the second one when the repository knows the database column. Yeah, that wasn't a good idea, but yeah, we have to fix that. Okay, let's talk about the use cases. As I said before, they contains code that encapsulate business logic. Okay. Again, more code, and then another bad idea. This is an example of a use case. Create negotiation from lead. Okay. Here we are just performing some operation. In the constructor, we are passing some collaborators. Now we have object, we can do that. We are passing 2 repositories and some data we are supposed to work on. And then we have an execute method which like performs some operation. Okay, creates models, another model, and then it saves it, yeah, in this way. Okay. So the content of the method is not really important. The idea is you perform business operation in a class, separated from the controller. Okay, and at one point we thought it was a good idea to make all use cases implements an interface. Okay, because yeah, so they are uniform. Okay. Yeah, it turned out it was a bad idea. Why? What's bad in, let's say, in this piece of code? Okay, I can tell you. Basically, here we are mixing collaborators, which are something that normally you inject when you create an object, with data, which is something that usually you get at runtime when you are processing a client request. So with this approach, we are mixing things a bit, and basically it's not clear, in my opinion, which data do we need to perform a particular operation. Okay, moving this oops down there makes more sense to me. Okay, and basically use case implements a very specific business function, so they are not interchangeable. Okay, okay, it doesn't make sense to implement an interface in that case, in my opinion. Again, it's easy to say that now, but we thought it was a good idea at that time. Yeah, as I said, now user cases are not interchangeable, and yeah, that approach enforces us to pass all the parameters in the constructor, missing collaborators and data, which is not good. Okay, what else? Yeah, when we were doing that, we got the opportunity to develop a brand new part of the application, new REST APIs. Okay, so we thought it was a really, really good opportunity to use the code we produce in the API island to just also write that new part. Moreover, we decided to create our own front controller to our routing and stuff like that. We want to just avoid adding, as I said before, bad code, okay, legacy code. Yeah, so new APIs are supposed to use only new code, the code in the API island, and as we have new code, we also could use it in the legacy part. So it was like a win-win situation. Let me show you again a bit of what we achieved. Here is basically our front controller from the requests, from the new API. Here we are fetching some configuration, yeah, performing some mapping some error handlers, and now we are creating our controller because now we need that. There are a lot of controllers here, ta-da-da, 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 and then here we map routes to controller. Okay, in that way. And here we have just implemented a sort of middleware when we have a small kernel and we add functionality wrapping the class in other classes. And yeah, why didn't we use here something like a framework or some components? Yeah, because we want to keep things simple, but if I had to do it now, probably I will use some sort of component like the Symfony router, okay? Because it doesn't make really sense to rewrite that part. I mean, you are going to reinvent the wheel for the same stuff, okay? But again, it's easy to say it now. Okay, so after a bit of time doing this kind of stuff, so refactoring, putting code in the API, and what was the status? How our API land was? So it was not so happy. Okay, maybe that's too much. Okay, it wasn't. The situation wasn't not that bad, to be honest. But it's just for you to get the idea. Basically, yeah, some bad code slipped in there, okay, or maybe code that doesn't respect the rules we decided at the beginning, like untested code or code that uses external dependencies. And external dependencies, I don't mean composer packages and stuff like that. Old code, legacy code, or yeah. Also, from an architectural point of view, some constraints were violated, like usually models should not know repositories. Okay, it's the other way around. Repositories knows and create models. Models are agnostic. Okay, well, some piece of code, just some models, just use the repository to fetch data from database. So it was not really what we had in mind. Okay, why this happened? Well, because you know you have a big team, and as I said before, it's not sufficient to fix what are you doing right now. You also need to avoid new bad code is produced. Yeah, in this case, the bad idea was being too much optimist about preserving code quality. Okay, so we have the API and we are fine. No, we are not. Okay, we need to enforce good habits when developing code. And we did that using weekly meetings where we, well, teach what we learned with like workshops or demos of the code we produce, or presentation about a particular topic like clean code or like testing. Okay, so for like we started with 1 hour a week. All the team we discussed about one particular topic, and in the long run it paid off. Okay, now things are getting better and better. Okay, what we discovered also is that the current directory structure in our API land wasn't good enough. I mean, we started really simple, like we created a directory for our controllers, one for our models, one for our repositories, and so on and so forth. Well, after a bit of time, all these folders ended up containing a lot of classes, because the application is really big. Okay, and yeah, we needed to refactor that. Okay, not from the code point of view, but from the directory structure point of view. We decided to divide the code in two main parts. The first one was the domain, which contains all the business specific code. Okay, so all the models, all the use cases, yeah, whatever, all things related to the business code, to the business model, yeah, sorry, to the business, should go in that directory. And then we have infrastructure that contains like common generic code, which is meant to be reused, yeah, all over the code base. Like, for instance, a mailer is something that you could put inside the infrastructure directory. And as we started to reorganizing this part of the code, some context emerged, like, okay, start popping up. Okay, for instance, we identified some few different contexts, okay, different parts of the application that made sense to keep cohesive in some way. So like we had marketing automation, which is all the part of the application which is meant to deal with marketing automation, so email campaigns and stuff like that. Chatbot, the part of the application which is meant to implement and interact with chatbots. Or telemetry, which is part of the application which is supposed to fetch data from external services about car statuses, so information like that. Inside every one of this context, we try to maintain a similar pattern. So this is an example for the telemetry context. Now we have controller, model, repository, use case. Again, it's the same as before, but since we gave a context, we have less classes, and it's easier to understand that everything that I will find here is related in some way with the telemetry concept. Okay? It's like just trying to apply some DDD concept to the directory structure. Make sense? Okay, sort of. Good. Yeah, but the idea is here was not doing that from the beginning. Okay, moving all this stuff around was not so easy, because when you have 8 people working on the same code base, and yeah, it was pretty difficult. We tried to do it in this smooth possible way and in the most rapid way, just saying, okay, this day we're going to work on that, so don't touch that part of code. And just after we finished, we ran the test, we were sure that everything went fine, because in the pipeline we got test, and then we said to everyone, okay, so merge that on your branches. It worked quite well, actually. Yeah, I want to spend a few words about testing. If you start reading a book about refactoring, you will probably stumble in something like that. Okay, if you want to perform a big refactoring on an application, you need to create a test cage. What does it mean? It means that you need to write some coarse-grained tests, like with Selenium or whatever, okay, which are tests that well, can tell you if the application breaks when you modify something. Okay, why you are forced to do this kind of test? Because if the application is not well decoupled, as it was in our case, you cannot write any integration test. There's no integration, everything is mixed. Okay, query on the database, reading on the network, manipulating array, you can write those kind of tests. You just need to test at a higher level. Okay, but these kind of tests are really, really expensive to write, really expensive to maintain. So in our particular situation, we decided to not go for that way. So basically we don't have in the old code base like end-to-end test or Selenium test or stuff like that. We decided to write several integration tests, several unit tests, and after that, yeah, still doing some manual testing to ensure that everything went fine. Moreover, the team also got a QA in the team. A part was responsibility was to perform QA. So yeah, we go for that way. Okay. Again, after a bit of time, we realized that we weren't able to perform like really, really big changes on the code base. Okay, for the new part is fine. Okay, the code new is fine. The new code is fine. But for the older parts, we weren't able just to perform small refactorings. Okay, why? Because we refactor a code while working on new stuff or fixing stuff, which makes sense for small refactorings, but it doesn't work if you want to change something at architectural level. Okay, so we changed the approach, and basically we started introducing, yeah, as I said before, no space for big refactoring. We started introducing what we call a technical debt board. You can tell it's a technical debt board because there is a side dog. Okay, And how does it work? Basically, every member of the team can populate the backlog of this board with whatever he found in the code base that thinks it doesn't work well. Like, okay, all this part of the code is not working, or is not clear what is doing, or stuff like that. Okay. For instance, here we have write better test fixtures, okay, or start using a dependency injection container, okay, which makes sense when you got a lot of objects, okay. Well, probably it's a good idea to start organize that in services and have an end when you need to create these services. Or, yeah, like, I don't know, yeah, some things on MySQL and stuff like that. So basically the idea is we started preserving some time just to work on these particular tasks. And this worked pretty well. We didn't achieve a lot of big refactoring from the code point of view, but we were able to perform, yeah, some operation that made, again, the code easier to understand and allow us to, yeah, delete a lot of code. For instance, we got a lot of external libraries that were not installed via Composer, but still linked, which is pretty strange, but yeah, that was the situation. And we were able to get rid of that. Also, we added database migration because SQL patches were applied by hand by the developers when they were developing. So, okay, so it's just a waste of time. You can forget to do that. It doesn't make sense, okay? Migration exists from a really long time, so it doesn't make sense to not use that. And also, we were able to work on continuous integration stuff. So create a build script, okay? Start inputting in there something like running the test, running integration tests, create a database, stuff like that. Okay, I wanted to show you, which maybe is not really interesting, but it's pretty straightforward, how to include a library through Composer. Basically, you have to, use a Git repository or whatever when you keep your code. Let's say here, this is the composer.json file of the library we want to include. Okay, makes sense? Here, basically, we are just saying nothing more that since, again, the library was pretty old and there weren't any kind of modern autoload like PSR0, PSR4. No, there were nothing like that. You just a bunch of files which were included using require once and require. Through Composer, you can just specify some files you want to be loaded every time in this key. So here we're saying, yeah, just load these particular files, which contains an autoloader for Swift Mailer. Or here we are saying, okay, I give you a class map. So when you find a class named that way, you can find it in this file. You can also pass a directory, and Composer will go through that and extract all the classes. It's pretty simple. It's not a big deal to implement it, but again, it allows us to like remove, I don't know, 300 lines of require ones through all the code. Okay. Okay, I'm almost done. I mean, this presentation is done. The work is not. So basically, the idea is, starting from now, again, we have a new API with new code. We are continuing eroding. I'm not sure it's an English word, but who cares? Code from all controllers. So we're trying to get them slim. And continue identifying context of the application and try to extract that and to make easier to understand how the code is organized, okay, and what are the relations between the different parts of the code. Yeah, there is still a lot of work to do. First one, like dependency injection, as I said before. Then there is a big work on like validating client requests. So using some like DTO or whatever. Okay, so wrapping all the data coming from the client that now are managed via array, again, in some specific classes, and use that to validate the data, okay, with that basically the DTO approach. What we learned during this experience, well, not everything can be refactored and also rafactored. Yeah, you can refactor everything. You just need to understand if it's worth it, okay? Because from some pieces of code will be too much difficult to refactor. You have to throw it away and just start clean. And also we learned that working on the code is not enough, okay? Because you have to do two things. First one, fix the wrong code you have, the bad code you have. Second one, avoid writing new bad code. Otherwise it doesn't make sense, okay? Okay, so I'm done. Thank you for listening. Thank you.